Hi, we are team number 4 and we will be solving the problem number 4. Hi, good afternoon. Here we have our differential equation y prime plus y equals to 0. So if we apply the solution for a homogeneous differential equation, we have y equals to c times e to the power of minus integration f of x dx. Well, if we do that, that gives us an answer of y equals to c times e to the power of minus t. So to prove that with another method, we have that the integrating factor should be e to the power of integration of ft dt. If we do that, the integrating factor for this differential equation is e to the power of t. So we have our differential equation dy over dt plus y equals to 0. We multiply all that by dt. So we have now y dt plus dy equals to 0. And all that we multiply it by the integrating factor e to the power of t. So now we have y e to the power of t dt plus e to the power of t dy equals to 0. So now we have the derivatives of mdx and mdy. It's e to the power of t equals to e to the power of t. So now it's an exact differential equation. We apply the integration of n dy equals to integration of e to the power of t dy. So now we have n equals to y e to the power of t plus g of t. We derivate g that and we have g prime t plus y e to the power of t. It's equal to m, which is y e to the power of t. Those y e to the power of t get cancelled, so we have g t it's equals to minus c. We apply that to yet plus gt. So now we have yet equals to c and y equals to c e to the power of minus t. So now we have the initial conditions y of 0 equals to 7. So now we have 7 equals c e to the power of minus 0, which is all that is 1. So we have c equals to 7. So y is equal to 7 e to the power of minus t. So now we will be applying the new method of Euler discretization. So we have the original differential equation y prime plus y equals to 0. So now we change that to y and t minus y and t minus t, all that over t plus y and t equals to 0. So we have y and t over t minus y and t minus t over t plus y and t equals to 0. Then y and t over t plus y and t equals to y and t minus t over t, because we're trying to find y and t. So y and t plus t y and t over t equals y and t minus t over t. So we cancel the t's by passing one to the other side. So now we have y and t times 1 plus t equals y and t minus t. So we have now at last y and t equals to y and t minus t over 1 plus t. And that's the Euler discretization. So now we have y prime plus y equals to 3t. If we apply the answer to the non-homogeneous differential equation, y equals to c times e to the power of minus integration of ft dt. So we have y equals to c times e to the power of minus t. E to the power of minus t would be our v. And to get the answer to the non-homogeneous differential equation, we multiply that v by u. We can get it by the integration of r over v. So u would be 3 integration of 3t over e to the power of minus t. So we have u equals to the integration of 3t by e to the power of t. So we have u equals to 3 by the integration of t to the power of t by e to the power of t. That it's an integration by parts. That would be u v minus integration of v du. So our u will be t, and du would be dt. Dv would be e to the power of t, and v it's e to the power of t. So we use the integration by parts formula. So we have 3 that multiplies t by e to the power of t minus integration of e to the power of t dt. So at last we have 3t e to the power of t minus 3 e to the power of t plus c. That it's our u, and all that we multiply it by v, which is e to the power of minus t. So at last we have y equals to 3t minus 3 plus c to the power of minus t. Then we use our initial conditions to find out c. We know y0 is equal to 0. So we have 0 equals to 3 by 0 minus 3 plus c by e to the power of minus 0. So that will be 1. And at last we have c equal to 3. So finally we have y equals to 3t minus 3 plus 3 times e to the power of minus t. So we have the same differential equation, y prime plus y equals to 3t, but now we're going to use the Euler discretization method. So we have y and t over t minus y and t minus t over t plus y and t equals to 3t. So then we have y and t plus t, y and t is over t equals y and t minus t plus t by 3t, all that over t. Then we have y and t plus t, y and t equals to y and t minus t plus t 3t. Then we have y and t times y 1 plus t equals to y and t minus t plus t 3t. So finally, at last, we have y and t equals to y and t minus t plus t 3t, all that over 1 plus t. Thanks.